In this video, we're going to look at using definitions of trig functions. So let's start by reviewing those reciprocal identities. We did start talking about these in our previous videos. Sine is the reciprocal of cosecant. So sine of theta is equal to 1 over cosecant theta. Cosine is the reciprocal of secant. So cosine theta is 1 over secant theta. And tangent is the reciprocal of cotangent. So tangent theta is 1 over cotangent theta. Likewise, cosecant theta is 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta. Using the reciprocal identities, determine the function value. So find sine theta given that cosecant theta is equal to the square root of 8 over 2. We know that sine theta is equal to 1 over cosecant theta, or the reciprocal of it. So 1 divided by cosecant is saying take the reciprocal, which we can just flip that fraction. So this becomes 2 over the square root of 8. Now, we have a couple things we need to do here. We need to simplify the square root of 8 because we can. We also need to rationalize the denominator. It doesn't really matter which order you do that in. I'm going to start by rationalizing the denominator. So I'm going to multiply both sides by the square root of 8 over the square root of 8, which gives me 2 times the square root of 8 divided by 8. Now we can simplify 2 over the square root of 8. Again, this order is sort of arbitrary. 2 over 8, I'm going to be left with 4 in the denominator. But now I need to simplify the square root of 8, and I'm going to come do that over here. So the square root of 8 can be factored to 4 times 2, and 4 is a perfect square. So square root of 8 is equal to 2 square root of 2. And I'm going to substitute that back in. So we have 2 square root of 2 divided by 4. And once again, simplify. This becomes the square root of 2 over 2. Determine secant theta given that cosine theta is equal to 1/2. Secant theta is equal to 1 over cosine theta, or the reciprocal of cosine theta, which is 2 over 1, or just 2. Now we're going to look at trying to summarize the sign, so positive or negative, of our function values, depending on where that terminal side lies, what quadrant it lies in. This does have including ranges, but we're not actually going to talk about ranges until we get to graphing our functions. All right, so depending on where our terminal side is, whether it's in quadrant 1, 2, 3, or 4, let's determine what the sign of our 6 trig functions would be. In the first quadrant, remember that x is greater than 0 and y is greater than 0. In our second quadrant, x is negative or less than 0 and y is still positive. In our third quadrant, both x and y are negative. And in our fourth quadrant, x is positive, but y is negative. Sine is equal to that ratio of y over r. Cosine is x over r. Tangent, y over x. Cotangent, x over y. Secant is the reciprocal of cosine, so r over x. And cosecant is the reciprocal of sine, r over y. Now, this table, we have those 6 trig functions in a little bit of a different order than we've seen. So it is really important that you're not just memorizing a sequence of values, but really remembering what these trig functions represent and their relationships. We also know that r is always positive because it's representing a distance. So in our first quadrant, okay, our first quadrant, x is positive and y is positive. So a positive for sine of theta, a positive divided by a positive is positive. For cosine theta, a positive divided by a positive is positive. For tangent, again, positive divided by a positive is positive. Now for our reciprocal functions, we're going to see the same sign as we did for the original three. So the reciprocal of sine is still going to have the same sign as sine. And that's a little confusing. I'm sure those captions are going to be interesting. But for cotangent, since tangent was positive, cotangent will be positive. Since cosine was positive, secant will also be positive. And for sine, or for cosecant, since sine is positive, cosecant will be positive. So what we see here is that if our terminating side is in quadrant 1, then all of our trig functions are going to have a positive sign. If we're in our second quadrant's over here, x is negative, but y is positive. So any values that are dealing with y are going to be positive. Any trig functions dealing with x are going to be negative. So sine is going to be positive, cosine is going to be negative. Tangent's going to be negative because there's an x in there. Cotangent's going to be negative. Secant's going to be negative. Cosecant, excuse me, is going to be positive. If our terminating side is in quadrant 3, where both x and y are negative, so if it's dealing with just x or just y, that ratio will be negative since r is positive. And then we're going to look at tangent a little more closely. So a negative divided by a positive for sine is negative. Cosine is a negative x over a positive y, which is negative. Tangent is y over x. That's a negative divided by another negative, which is going to give us a positive value. Since tangent's positive, cotangent's also going to be positive. Secant will be negative. Cosecant will be negative. And if our terminating side is in the fourth quadrant, x is positive, y is negative. So anything dealing with x is going to be positive. Anything dealing with y is going to be negative. So sine is negative. Cosine is positive. Tangent is negative. Cotangent is positive. Sorry, it's still negative. I'm thinking of r. Cotangent is negative because y is negative. Secant is positive and cosecant is negative. Now, looking at this, kind of taking this chart with all these signs, plus or minus, looking at this grid, we can summarize, and there's a nice little acronym that we use, ASTC. And what that tells us is that in this first quadrant, all of our trig functions are positive. In our second quadrant, sine is positive, and then also cosecant because of the reciprocal. In our third quadrant, the only ones that were positive, if I'm looking at this list, were my tangent and cotangent. So tangent is positive. And in quadrant 4, only my cosine and reciprocal of cosine was positive, so cosine. So ASTC, again, going through our quadrants as they are numbered 1, 2, 3, 4, will tell us which of our trig functions are actually positive in those quadrants. So that might be a helpful tool for you as we continue on. Determine the sign of the trig function of the angle given. An angle of measure 54 degrees. So we are indicating that these are measured in standard position. So starting at our positive x-axis, a positive angle would move counterclockwise, a negative angle would go clockwise. So 54 degrees, I'm going to sketch this. 54 is less than 90, so it's going to be somewhere here in that first quadrant. Since it's in our first quadrant, we know that all of our trig functions are going to be positive. 300 degrees. Again, sketching it, starting at standard position and going counterclockwise. I always have to think about that. If I start here, let me use a different color. Here's 90 degrees, here's 180, here's 270. 300 is going to be even beyond that, but not quite to that positive x-axis, because that positive x-axis would be 360 degrees. So 300 degrees, an angle of 300 degrees, has its terminating side in quadrant 4. In quadrant 4, only cosine is positive. So cosine is going to be positive, and then its reciprocal secant is going to be positive. The rest are going to be negative. An angle of negative 200 degrees. So again, we're starting in standard position. So we're starting at that positive x-axis, but a negative angle we're going to measure going clockwise. So starting from the positive x-axis, here's negative 90, negative 180. If I go to that positive y-axis, that's going to be negative 270 degrees, and I'm not quite there. So I'm going to be somewhere in here. Which means that an angle of negative 200 degrees is going to terminate in quadrant 2. In quadrant 2, only sine is positive. So sine is positive, and then its reciprocal cosecant is also going to be positive. The rest are going to be negative. Identify the quadrant or possible quadrants of an angle theta that satisfies the following. So we know that sine is going to be positive and cosecant is going to be positive. Sine is positive in quadrants 1 and quadrants 2. Okay, again, looking at this chart, everything is positive in Q1, sine is positive in Q2. And then cosecant, again, is positive in quadrant 1, and then cosecant being the reciprocal of sine is also positive in quadrant 2. So Q1 and Q2. The overlap, so having both of these satisfied, does occur at Q1 and Q2. So in quadrants 1 and quadrants 2, we see that we've got positive sine and positive cosecant. B, we're looking at tangent being negative. So again, looking at our chart up here, everything's positive here and tangent is positive here. So that means tangent's going to be negative in quadrants 2 and 4. Secant is negative. That's where cosine's going to be negative. So cosine is negative, or let me start with where it's positive. It is positive in the first and the fourth quadrant, which means the second and the third quadrant are where cosine is going to be negative. If cosine is negative, that means secant is also going to be negative. Since we need to satisfy both of these, the only quadrant that satisfies both is Q2. So only in quadrant 2 would we have a negative value of tangent and a negative value for secant.